stay. That gets in the way of your understanding. And if some of you guys are like, I don't care, man. Give me my songs. Well, go talk to somebody else. I'm not going to give you many songs at all. Sorry. I'll leave the singing to the people that can do it. So let's try a problem with quotient rule. Then we'll talk about trig functions, and then I'll shut up for a little while. Oh yeah. Oh, it's Wednesday, isn't it? Yes. So I got a little more time now. All right. Now hopefully you guys understand, if I were to put it as x squared minus 5 over x or something, I don't have to use quotient rule because I can just split it up, right? Whenever the bottom is a monomial, whenever there's one term on the bottom, I can rewrite it as the division of several terms, right? And then students think, oh, I can make this x squared over x squared over 5. That's bullshit. Please, dear God, nobody do that. Because that is so bad. I can't break it up. There's more than one term on the bottom. Too damn bad for me. So I have to use quotient rule. So what's the rule say I got to do? Oh, first. So top derivative first times the bottom. Minus
the top.
Now the bottom gets a turn, right? So it looks like product rule. So minus, of course, because when you do the derivative of this one, it came from the bottom, that negative power would come out, make it a minus. That's why there's a negative there. Over x minus 5 squared. Josh, you don't like that at all, do you?
I mean, you've answered it like twice. Why the bottom squared? But I just don't know where you got it.
When we get to chain rule, I'll really be able to show you. Because I could show you the derivation using the limit definition, but if I'm a student that still is kind of like, because I do weird shit in the middle of it and it still is not satisfying. Once we learn chain rule, I can then do this derivative. Right? If that was just an x, I could do that derivative all day. But the minute I have a function inside of another function, that is a weird-ass derivative. I need some other rule, the chain rule. So once we learn chain rule, I can come back and really show you what the hell. But real quick again, if I took this guy's derivative, a negative 1 would come down, and that would go to a negative 2. Right? What's the derivative of this? What's the derivative of this?
Oh, okay, yeah.
All right.
Sorry about that.
That at least explains why there's something that it's squared. It kind of makes sense it's on the bottom squared because that would become a negative 2.
Yeah. Okay, yeah.
I like it. Doesn't really explain why the rest of it kind of goes where it does. But and now, what's this derivative?
2x.
2x, and can we multiply it in at the same time? Is that right? 2x squared minus 2x times that. All right, thank you. And derivative of that is just
1.
Sweet. All right, how are we doing? Is that cool? And now you just put together your like terms. Yeah, there 2. Does it factor and reduce it all? No. Of course not. Good. Now, yes, sir.
What did you get, the 10x?
Oh, derivative of this is 2x, and then I distributed 2x.
Can I just keep it to then maybe cancel with the bottom?
Oh, shit. All right. Sorry, I didn't mean to call you out, but I did anyway, too bad. If I did this, and this derivative is 1, right?
Yep.
It's gone. So please, dear God, hell no. I'm not even going to be nice about that. Hell no. You know this. You can't. Holy shit, no. So, can you reduce 4/3?
No.
Can you reduce 4/3? Hell no. Even though 4 is 3 plus 1, right? You can't do that because division is not the opposite of addition. So you can't cancel part of an addition or subtraction problem. You can't with division. Division is not that strong, I guess, or it doesn't do that job. I'm sorry to point, because a lot of people do that, trust me. You just happen to be the one that said something about it. I didn't mean to come off it. Well, this is a quick way to make me just cry. You want me to cry? That's a quick way to do it. Please stop doing that. All right. So that's quotient rule. Right? And you got to trust me, if you write the rule, things just become so much easier, and you start to really, really learn the rule better if you write the rule. So what do we know about trig functions already? We know that if I get sine, the derivative is... No. It's cosine.
And then it goes negative.
Yeah, then it goes negative. So let's, real quick, I don't know how much time. If I wanted to know the derivative of cosine... Yeah, but and two reasons real quick. It makes sense that they're going to alternate somehow. What's the slope here?
1 or 0.
0. All right. What's the slope here? What's important is it's negative, right? So it'd be down here. And what's the slope there? 0. So what's that look? That looks like negative sine, doesn't it? Sine normally goes like that. This is going like that. So that's a real quick, not nowhere near good enough for proof. But it should feel right that they would alternate, because the picture looks the same. It just kind of moves and moves and moves. But this becomes the derivative of that is negative sine. Now, what's really neat is when we learn all the other trig functions, whenever you take a derivative of a blah, then you get negative something. All the derivatives of the co-functions come out negative. It's a really nice, quick way to remember. You guys, so let's do that. Now that we know quotient rule, gesticulate. Sorry, I just like to make fun of myself. Gesticulate?
Yeah, I was like, I thought I heard you say something else. I was like,
oh, no.
I was like, what did you say?
I like it. Let me see, wait a minute. Oh, so what if I had tangent? Well, let's prove it. It's one thing to know what something is, what know a fact, but if you prove something, that's more impressive. So I can rewrite this, of course, as... And now I can do its derivative. Because now I've got it written in a form that I know the rule for, with functions that I know derivatives of. So I would get, what do I get? What's the rule say I got to do?
Bottom times derivative of
Yeah, sine x, top first. That's all you need. Top first. So top first, minus. Now the bottom gets a turn right. All over.
bottom squared.
Coolness. That's the rule. That's the quotient rule. So I just wrote the rule. Now I'll do the derivatives. What's the derivative of sine? What's the derivative of sine?
Cosine.
Cosine. Cosine times cosine. It's crazy. What's the derivative of cosine?
Negative sine.
Negative sine. Sine times negative sine. Negative sine, so sure I get that. Are you guys with me there? Is that good? Yes, yes. Derivative of cosine is negative sine times negative sine is plus sine squared. Yeah. All over cosine squared. So, of course, cosine squared x, sine squared x is 1. And what's 1 over cosine squared? Secant squared. That's why it's secant squared. I love it. So, derivative of tangent is secant squared. Now, let me see. What do you think the derivative of cotangent is? Yeah, the beautiful thing is, once I know one, I know the other one. Cotangent's derivative, it's co, so it's negative cosecant squared. I like it. And you can prove it the same way. How would you rewrite cotangent? As cosine over sine. You can go through the whole steps and you get there. But it's really nice to see the symmetry amongst the functions. Alright, so I think that's enough for you guys to try out. So on the bottom of your grade sheet summary, there's some problems I want you to try out. They use product, quotient, and trig stuff, and exponential stuff. Everything we've just talked about. All the things. On half a sheet of paper. So if you want to work for somebody else and you don't want them to know your grades, just fold it over. There you go.
Real quick, I did not get one of those sheets earlier. Under Kyle.
Yeah. There you are. Oh yeah. I'm sure I'm thinking somebody else's stuff. Anybody else you need theirs?
Yeah, it'd be nice.